Great, yeah, thank you. Thank you very much, Nina, and also thank you to both of you, Nina and Michael, for organizing this. And yeah, Rita and I had a chat beforehand and decided that I was going to go first and give you some general context on heat adaptation. And my focus is on heat stress and heat adaptation planning, in particular relating to the project, as Nina just mentioned, that we have currently underway, funded by the Innovation Campus Sustainability on heat adaptation planning in small municipalities. Let me see how this works. Yeah, okay. So just to cover the basics, and I'm sure you're familiar with this, excuse me. And unfortunately, some of the graphs here are in German. Yeah, are in German. I hope you can relate to them anyway. We've had, unfortunately, not very much success with arresting or reducing global warming. And we have in Germany already a temperature increase of 1.6 degrees since pre-industrial or early industrial times. And one of the key things that affect that are the result of this climatic change is an increase, a substantial increase in heat days. As you can see, 196% since 1951 even, which is a relatively short time period. And you can see on the right-hand side how the number of hot days, so hot days, meaning days over 30 degrees, with temperatures over 30 degrees, has changed in this period since the early 50s quite dramatically. And what you can also see there on the right-hand side is that in southwestern Germany, in the Upper Rhine Valley, we are really in one of the hotspots of this development. Another one is the Rhine-Main area, but also large parts of eastern Germany, Brandenburg in particular. So, why is this a problem? Well, the urban heat island effect is probably something that also some of you are familiar with. Essentially, the built environment heats up through storing thermal energy in the daytime. In particular, concreted surfaces heat up very significantly. And then it depends a lot on wind patterns and fresh air flows during the night. And if that is not sufficient, then there is a lack of nighttime cooling. And traditionally, and for many years, people looked at the urban heat island effect predominantly in large cities. But more recently, it's also become more of a topic in smaller municipalities, and also another focus on indoor heat, which is not something I'm going to focus on today. But we know that even in smaller municipalities with around 10,000 inhabitants, there can be an urban heat island effect of 4 degrees. That means that the temperature in these towns is 4 degrees higher than in surrounding areas, in surrounding rural areas. So this heat stress that builds up in these areas, in these settled and built up areas, is quite substantial, especially when we looked at perceived temperatures. So if we have an air temperature of around 30 degrees, the perceived temperature of someone standing between two buildings on a concrete surfaces wearing a suit, like in this pictogram here, without any shading can be up to 45 degrees. Whereas if the same person was actually wearing appropriate clothing, moving, and be in the context of a shade tree on a grassy surface, this can be reduced to 25 degrees. So you can see there's a massive difference, right? Why is this important? It's really, really critical for human health. This is something we have known for quite some time, at least for 20 years, since the 2003 heat wave across Central Europe, where we've had masses of excess mortality in relation to heat. You can see this graph here, an analysis of the impact on mortality of this heat wave in Paris, where it increased mortality by 142%. And you can nicely see how, when you follow the black graph, that's the actual mean temperature in the year 2003, compared to the gray line, which is the mean temperature in the 3 years beforehand. You can see how the heat deaths occurred. That's the bars basically pointing upwards, increased substantially after several days. So it's also very important to be aware of the length of heat waves, which is predicted to increase with climate change. The longer the heat wave continues, the more deaths we can expect, and that has a lot to do with the urban heat island effect and the lack of nighttime cooling. Bodies not getting any rest during the nighttime. In Germany, this heat wave is said to have claimed around 7,000 excess lives. And what's really important here, which is probably not so well known, is that heat events have caused 99% of extreme weather related deaths in Germany since the year 2000. So 99%. What we hear in the media is usually deaths related to flooding, sometimes also the old story of course, equally tragic people being hit by trees. But really, heat is the main killer here, and this is really, really important. Yeah, it relates very strongly to cardiovascular, but also other like respiratory illnesses. And in particular, it affects so-called vulnerable persons, a very complex term that I'm not going to go into a lot more detail today. These health risks due to heat stress, they are listed on the right hand here. See here, sorry, there's a bit of a German mix there still. It's usually combined, heat events are usually combined with periods of high ozone and also strong UV radiation. And this combination is really very dangerous and can lead to death without going into a lot more of the physiological detail here. But probably some of you have experienced at least some of these heat-related stress symptoms before, hopefully not any of the more serious ones. The perceived thermal comfort is something that we have started to, not we, but people have started to measure in the last 30 years, and they've come up with the physiologically equivalent temperature, PET, which you might have also heard about yet. PET basically covers different grades of thermal perception in relation to physiological stress, in relation to a person that's doing light activity like we are doing right now, perhaps seated, and that wears a certain type of clothing. And you can see that the range where we feel comfortable between 18 and 23 degrees PET is relatively limited, relatively narrow. And as soon as we go below a PET of 4 degrees Celsius, that's already pretty strong cold stress. And beyond 41 or even from 35 onwards, we're talking about significant heat stress. So this is a parameter that's used increasingly. And this brings me to our project. So in our project, we are focusing on heat-related adaptation planning in a small municipality. It's a relatively short project, only 12 months, so we don't have a lot of time, nor have we got a lot of capacity to do this on a broader scale. But nevertheless, we think it's really important. It's basically a project that's trying to prototype heat adaptation planning as a process, as a planning and decision-making process for municipalities, and in particular for very small municipalities. The project is called Prolog. That's the acronym. We went through a process of basically asking municipalities to apply. And we had some applications, and we ended up choosing the municipality of Ihringen at the Kaiserstuhl, not far from Freiburg, which is also known as being the warmest place in Germany. So that's an interesting fact, of course, in relation to this. And Ihringen is, a very typical small community in many ways, 6,300 inhabitants. Still quite a lot of agriculture, but also some commercial areas, some tourists, Demographic change is also taking hold in Ihringen, but there are also some young families because it's very well connected to Freiburg and so on. And the mayor of Ihringen, Benedikt Eckele, said the health and well-being of our residents, especially the very young and the very old, are of particular concern to us. Participating in the project offers us the opportunity to work with our citizens and local stakeholders to develop customized solutions to combat the increasing heat and thus ensure a sustainable quality of life in our community. He obviously said this in German and not in English, but it's an interesting quote because it picks up, there are some key words in there that I think we need to look more closely into. First of all, an opportunity to work with local stakeholders. That's something I'm going to get back to in a minute. But also customized solutions and the relationship here between the perceived relationship between doing heat adaptation planning and ensuring quality of life. Yeah, so it's really also something that's very much future oriented, very strategic, a very necessary strategic process for these communities. With our partner KIT, so the Karlsruhe Institute of Technology, the Süddeutsche Klimabüro, they have worked with some regional climate data that's soon to be published also as part of the Klimaatlas Baden-Württemberg. And they have done model simulations for an idealized summer day. That's why it says the 21st of June as an idealized summer days for 2 p.m. And you can see roughly what the PET, the physiologically equivalent temperature, is like in this municipality. The pink lines are the building footprint, and the black lines are the commercial areas, the commercial district. And there's also a similar one on the right-hand side for Wasenweiler, which is part of the municipality of Ihringen. And you can see that there's some really interesting patterns here, even in this rough sort of like resolution, course resolution. We have, and this is in German, unfortunately, the school, we have the town hall, we have kindergartens, we have a nursing home, and playgrounds, all in this area that is particularly prone to heat on the left-hand side here. If we then really look more specifically at moderate heat stress, so that is temperatures exceeding 30 degrees PET, then we also have a similar pattern that a number of these very important services for, especially in a social context, for good reasons, are very centrally located, and that means they are more prone to heat stress. In Wasenweiler, interestingly, on the right-hand side, you can see that the school is on the edge of town, so that is really beneficial in terms of protecting school students from heat stress. I was said before that the nighttime temperature really matters. So this is a thermal stress graph using the same data, but this time it's air temperature at night. And you can see that in some areas, the temperature will stay above 20 degrees, and above 20 degrees at night is what is called in the German context a so-called tropical night, which also means the body is really struggling to cool down. So that really is really critical in this kind of like built-up heat stress situation. Yeah, there's another one here that again, sorry, it's a little bit mixed again with the languages, but this is where you specifically see where the minimum temperature stays above 20 degrees in this so-called tropical night. And that means people living in those areas will really struggle to get a restful night's sleep in this modeled data here. When we look into the future, so these graphs that you just saw, that's the current situation. But when you look into the future, you can see that, and again, it's in German, summer days and hot days, Sommertage and heiße Tage are projected to increase quite substantially from currently between 50 and 65 this is summer days above 25 degrees to 97. So that's dramatic. but also hot days above 30 degrees from currently 11 to 20 roughly to around 46, or a doubling at the end of the century. And also, in between, there is a lot of variability in this data, but this data was generated as part of a previous project called LOCLIM. So this means we have to do something, and the communities have to do something. So just to sort of like come to the end, to talk a little bit about the project. The project Prologue uses a transdisciplinary approach. That's partly also why I think the ICN was happy to fund it. The project aim is to develop and test a feasible heat adaptation planning process, specifically targeted at small communities, small municipalities with limited adaptive capacities. So this is to say there are lots of guidelines out there already about how to do adaptation planning in the heat context, but a lot of them are way too complex and too cumbersome, and also require substantial staff capacity and other capacities that are not suitable for very small administrations. The approach is participatory action research supported by empirical social research. So one of our key approaches that we have taken from this previous project that I just mentioned, LOCLIM, that we developed there, is involving civil society and other stakeholders from outside the municipal administration in the process, because the administration themselves are probably not in a position to administer this process and to make it meaningful by themselves. We also have supporting empirical research, a master thesis on long-term heat adaptation planning, and another master thesis that looks into stakeholder constellations. Where are we at? We've just recently held our first stakeholder workshop, which was very much about a stocktake of current vulnerabilities to heat, perceived vulnerabilities to heat. It was very well attended. We also had some first discussions about possible actions in Iringen per se. But the main goal was to really understand where is the municipality at and which actors are involved in what sort of activities. And one of the key discussions that we had in these small groups that you can see here on the picture, for example, focused on schools and kindergartens. And we had representatives from kindergartens and from schools, primary schools there, who talked about just how severe the heat issue is for them in summer, and how they sometimes have to send kids home, although technically they're not meant to do that, because it's just not possible to maintain a healthy environment for them. And that's the end of my talk. I've got a few questions for discussion for after Rita's talk. These are questions that we are currently concerned with in this project, but they also sort of extend a little bit beyond that. How can small municipalities best engage in strategic and long-term adaptation planning? So it's an urgent task, but often it's a task that goes beyond their capabilities. And maybe I'll add, it's also a task that will become compulsory in some form as part of the federal adaptation law that was passed earlier this year. How can people become more sensitized regarding their own, but also others' heat vulnerabilities in this local community context? Whose help can be enlisted in identifying and protecting vulnerable people? And what could be the roles for researchers in promoting heat adaptation in areas and contexts where capacities are limited? These are just some questions to maybe trigger some discussion later on, but I'll stop there and thank you for the time and hand over to Rita for her talk on her project. Thank you.
Thank you. Let's see if it also works with me. Yes. Okay, so yeah, so we did agree to try to find something in common. What I'm gonna present you today is actually the results of something that would not have happened if I was not at FRIAS and not at YAS. So this is the young generation of the Young Academy for Sustainability Research. I was at FRIAS for 2 years, and the results I will present today were developed during these 2 years. So I presented it already like a couple of times, inclusive at FRIAS. So maybe you need to invite me again next year to actually present something new. But I will try today to do a short recap of what we developed, and this is just one example of the many projects. So I also invite you to look at our webpage and look at the other projects. But starting with a little bit of background so that you understand why my project is about what it is because I'm an ecologist. My background is in forestry, but more and more I work with cities. And I really like this picture because sometimes there is this conflict for space, and we tend to think there is no space for trees in cities. But this is a nice example of integration. So how can we accommodate trees also in the cities, and why should we do that? Why should we care? I think we should care a lot, and that's part of what I'm gonna show. And Hartmut show pictures from another town in Germany, but I'm gonna show you about Freiburg because we actually also have this data about the importance of heat mitigation. And if you think about Freiburg with the Black Forest next to the town, so around town, but still in summer, these are data from 2022. We got almost 40 degrees in Freiburg. So it touched upon all the different cities, small and large towns, and even if you have a lot of green around your town, it still can get pretty hot. And this was one of the motivations why we started the project, because I did it with another colleague from the academy, Chad, and we were looking at, well, what can we do to solve the problem? So there is a problem. Hartmut explained it quite well. He also talked about the impacts on human health. And we tried to explore one of the possible solutions. It's not a silver bullet that fixes everything, but we had to start somewhere. So it was all over the news. And if you look at this picture, also in the news about Germany having the hottest day of the year, if you look at where people is standing or sitting, is under a tree and close to the water. So this is like something that people do naturally, right? If it's too hot, you try to find a shade. And if you are outside, most often you found these places under a tree. So it's not just us casually finding out about this. There was also this study a few months later that actually said, yes, we have a huge problem with heat-related mortality. And if European cities would double their canopy cover, we could avoid 2,600 human deaths, which is quite a lot if it's all about canopy. As a disclaimer, this is not that easy, right? So in some cities, doubling the canopy cover might be going from 5% to 10%, which is more or less achievable. But if you are talking about a city with 20%, maybe that's already good enough, and then you just need a little bit more. So different cities need to put more or less effort, but as a general idea, this is a way to start. And why that and why trees are so important, and I like to show this example. So you have the map of the city, and this is one of the hottest spots. This is Montreal. So it's this is like a commercial area, so a lot of paved surface, but also a lot of residential house in a not so healthy neighborhood. And then you have a park. So the more red the colors, the hotter it gets. And you see how different it is to have a park nearby. And even the small parks, so you don't need to have such a huge park, but even the small ones, they make a difference. So there is this opportunity. You see, it's just this tiny bit spot here. They really make a difference in cooling. And sometimes if you don't have a space for a park, you can also think about just planting trees in streets. So this is an example from Poland, where you have in the same city and the same day at noon, where they measure temperatures in two different streets. And as you can see, it's more than 10 degrees difference between the two streets. So these little interventions that cities can make to try to alleviate the heat stress. And even zooming in even more, this one is from the Netherlands, from here where I am now, where they start replacing the paved surface where you can park your car with just a little bit more grass. And you can see that here it goes a little bit above 20 degrees. And if you don't have any green, the pavement can hit above 30 degrees. So again, like a huge difference in the temperature just with a little bit of greening. But I tend to focus on trees, and they do the cooling mostly through shade. So just the shade effect, you go, it's not so hot, but also at a larger scale of the city through their evapotranspiration that also helps cooling down the temperature of the city. So this was kind of like the motivation for our work and theory behind it. And then what we did was we did a survey. So we were not going to measure the temperature, but we wanted to know, like if you remember that first picture where people were sitting under the tree, we wanted to know how much do people actually use green spaces during said normal days, and if that changed when the weather gets really hot. So we did a survey, the first one in 2021, all across Germany. We had 5 case studies in 5 cities with different canopy cover, so very few trees to a lot of trees, and also a different population density. And then we also had a sample, like a national representative sample. So that we could look at specific case studies, but also what would be representative of the whole of Germany. And we had some basic questions about use of green spaces, because if people don't use them, then it also changed whether or not you should invest on them. So you wanted to know, how often do you go? What activities do you do there? Do you go with friends? Do you go alone? Do you go for play sports? Is it easy to get there? Do you have to travel a lot? And the first results was it's actually quite easy to get to a green space, at least from the population that we survey. If you compare this with studies from other European countries, but even from, or even more different from North America, it means that in Germany, it's much easier to find a nearby park than in other cities. And they are also quite happy with how the space is maintained, so that they enjoy being there for the quality of the greenery. So this was our starting point. And one of the recommendations for health, not just for it, but for the well-being, is that if you take a 15 minutes walk, can you reach a green space? And in our case, over 60% could reach that park. So we meet that kind of baseline or requirement. And when we asked about what are the reasons to go there, we found out that more than 65% go there because they expect these positive health outcomes. It's important to say that after the pandemic, the appreciation for green spaces and the benefits really skyrocketed. So we are a little bit collecting the benefits from that. But as our research question was whether or not people use green spaces as a cooling strategy, when we asked them if they use that during warm days, the number went down from 60% to 30%. So even though we know that green spaces help cooling down and you have the parks with shades, people do not associate going to a park as a cooling strategy. And we did a little bit more. We gave them different options of what they would do when it gets really warm. And we split our sample in those that felt higher discomfort from it, from those that did not felt anything. And we noticed that people avoid going outside, which kind of makes sense. And it's also what sometimes the public health authorities tell people to do, to stay home. Sometimes the homes can get really warm as well. So we asked about using fans, and we looked at like visiting urban parks, still ranks above going to other cool places like movie theaters, a shopping mall, a library. So it's still ranking higher, but not as higher as we had hoped for. what is also interesting to notice here is that people that feel a higher discomfort from heat, they actually avoid going to the parks more than the other that do not associate with it. It's still higher for those that feel discomfort. They still go more to a park than they go to another cool building, or that they have air conditioning, they use it. But still, it was a split. So really, the connection between there is a park, I couldn't go there to get cooler, it's not there. And going a little bit more into the impacts of what we found out, something interesting, and Hartmut mentioned that about the young and old people being the most vulnerable population. Actually, what we found in our case was the older people were not most impacted, which was not what we hypothesized at first. And what we thought, it might be that they are just less exposed to it. So if they are not forced to go to work, if they are not forced to commute, maybe they avoid this exposure, and that might make that they are less exposed to it and they suffer less from it, or that they are more aware and just simply take more precautions than young people that decide to go out no matter the weather. So we are not the first to report this, but still something to pay attention. And when at first I said that maybe you should invite me again next year when I have different results, we decided to repeat the survey this summer. And we did it rather differently. We wanted to survey the same people before and after a heat wave so that we could trace the change of their behaviors. But if you remember this summer, it was not particularly warm. So every summer has been hotter and hotter, but this summer that we had a project going on, it didn't get that hot as we had hoped for. So we had to postpone. Finally, these are just some very preliminary results. But what you see in this graph is that before the heat, only like little more than 15% would report, for instance, difficulty falling asleep. And the number of people that report difficulties falling asleep or having a good quality of sleep went over 50%. And controlling for all the other factors, what we could expect that changed was the previous 7 days had been warmer than usual. And this is quite a lot. Even for decreased productivity, it goes almost 20%. So in economic terms, this is also something that needs more attention. But let's talk about that in the future. Just to finish, just to link with also something that Hartmut mentioned. In our research, we also like for support for policies, because sometimes we need to tell policymakers what needs to be done, but also like that the society is willing for that. So we did ask for several different measures. In this case, I'm only showing like planting more trees. We also asked about creating more green spaces, but also like just changing the pavement and the rooftops, or like subsidizing air conditioning. And you can clearly see there is a difference in the level of agreement and support. So the support for planting more trees and for having more green spaces is way higher than the other options that we suggest. So there is some room for actually implementing these strategies. And one of the places where to do that is schools. So Hartmut mentioned that in his example, some of the places that were more exposed to it were schools and kindergartens. And this happens in pretty much every city. They are also in the city center. So there's a reason for that. This example is from Paris. They also show like the mortality after the 2003 heat wave in Paris. And they have this really nice project. Well, I think it's already finished, but they started there that they try to green the backyards of schools. And that's because at some point in the center of Paris, they would have to cancel school because it was just too hot for the kids to come outside and play. So what the project started doing was picking up some schools. They start in like the poor neighborhoods, but they are doing that kind of at scale, and they start greening. And what I showed you before, this is how it looks now. So in B school, they made these spots where the kids can plant and do some gardening. But in other schools, it went from something like this with one single sad tree to something like this. So completely different. It's not always easier. The next example is this one. The parents and the teachers didn't want to change from the left to right because they said, if we do that, the kids have no place where to play soccer. And there is no way. This is a playground. This is for them to play. So it really took a lot of time for like the whole community. The municipality had one of the strategies they decided was to open the schoolyard during weekends so that the population could also use this space. And in time, you can see that it completely changed. And today, the school is used as an example of a community project where the greening really took shape, and it was well welcomed by the whole community. So there is many opportunities to do greening at a small and a larger scale. What is the backyards, the front yards, the street trees, the parks, or the schoolyards? Yeah, so that was my part, and thanking again for funding this research and for also the great time that I had at FRIAS, and also take care of the trees. That's the message. Thank you.